this is lecture number 6, in which we are going to discuss about elements and mixtures. So first of all, let's start with the formula units. And in formula units, we are first going to discuss about pure substances, and chemical formula. So what are pure substances first of all? So pure substances are the one which contains which has constant composition, whose composition does not change. So it has constant composition, and they are basically consist of the same type of particles, like one type of particles. So the other thing is that they contain only one type of particles, and those particles could be atom or could be molecule. So these are basically pure substances. Now let's discuss about what is basically atom. So atom is considered to be the small building block of a matter. So it is the smallest building block of matter. Like you can say the smallest part of a matter. And the pure substance here, the pure substance that is divided into either elements, or they can be divided into either compounds. So elements are basically the one which consist of only one kind of atom. So it contains only one kind of atom, and they could be, you can say, aluminium, they could be oxygen, they could be carbon, they could be hydrogen. You can see elements, they contains only one type of atom. And what are compounds? Compounds are basically the one which are formed by the combination of atoms. So they are formed by the combination of atoms, combination of atoms. And combination of atoms, you can see, like for example, we have, let's say, carbon dioxide. So you can see these are the elements. Carbon is and oxygen are the elements, and the subscript there, this is basically the subscript, and this represents the number of atom. If there is no subscript there, then that means it has only one atom. Now let's move further, and then we are going to discuss about the molecular compound. So in molecular compound, they are basically composed of individual molecules. They are composed of individual molecule. And how does a molecule is formed? So molecule is formed by the combination of two atoms, by the combination of two atoms which are covalently bonded. Like for example, we have water. We have water, and we know that this water is basically formed by the uh, covalent bond between oxygen and hydrogen. This is oxygen, this is hydrogen. Oxygen has two lone pairs on it. Lone pair means the non-bonding pairs. So you can see that this is a covalent bond, and we can say that water is basically a molecular compound. Water is a molecular compound that is basically formed by the combination of two elements. Now let's see what we mean by an ionic compound. Because we have discussed about molecular compound that is formed by the combination of two atoms which are covalently bonded. You can see which are covalently bonded. So now let's move further, and now we are going to discuss about ionic compounds. So first of all, ionic compound is formed between metal and non-metal by transfer of electron. So then we have the formula unit. Formula unit is the arrangement of atoms or ions in fixed proportion by an ionic bond. So what does formula unit represent? Formula unit. What is the formula unit? Formula unit tells us the arrangement of tells us about the arrangement of atoms or ions in fixed proportion by an ionic bond. Like we have sodium chloride, which is an ionic bond, and because its ions are held together in a fixed arrangement by ionic bonds. So we have NaCl, and NaCl is basically an ionic compound because Na is a metal and chlorine is a non-metal. So that is basically an ionic compound because the ions are held together in fixed arrangement. Then we have law of definite proportion, and the law of definite proportion states that the ratio of the masses between the elements in a compound is always the same. So it states that the ratio of masses between the elements in a compound is always same. is always same. Like for example, if you see the water, so if you are seeing the water, then you are going to see that there is the mass of water, and mass of water is 18 gram. And from the other source you have the mass of water, which is 180 grams. So what is going to be the mass of hydrogen there? If you want to find the mass of hydrogen there, then you are going to see the mass of hydrogen in water is 2 and oxygen is 16. So it would become mass of hydrogen in 18 gram would become 2, because total molar mass of water is 18. And if it becomes 180, then we have to multiply 2 with 10. Then that becomes 20. And the mass of oxygen is how much? Mass of oxygen is 16 gram. And here it would become 160 gram, as we have to multiply again with 10. So it becomes 160. And now if you want to find out the ratio of hydrogen and oxygen, you are going to see it is going to be 2 by 16, and this is going to be 20 by 160. So the final ratio comes out to be 1:8. So you have seen the ratio of the mass remains the same. Now let's move further and let's discuss about empirical formula and the molecular formula. And what we mean by molecular formula? So empirical formula tells us the simplest, it tells us the simplest whole number ratio present between the atoms in a compound. And what does molecular formula tells? It tells us the actual number of atoms present in a compound. Like for example, we have glucose. The molecular mass of glucose is, molecular formula of glucose is C6H12O6. If we want to find its empirical formula, then simply we know that 6, 12, 6, it can be divided by 6. And the ratio would become C, H2 and O. Then we have like benzene, C6H6, this is benzene. And then benzene can also be made into an empirical formula by dividing carbon and hydrogen by 6, so it becomes CH. Okay, like we have let's say we have butane. Butane is C4H10, and its empirical formula can be found by dividing by 2, because maximum it can be divided by 2, so it would, this one would become C2H5. This is going to be its empirical formula. Now if we want to like in the exam which kind of question they are going to give us, So let's see those questions. Like they are going to give us calculate the empirical formula of a compound which contains. So this is the question. They want us to find the empirical formula and they have given us the masses. So first we are going to write calcium here, then we are going to write chlorine here. So calcium is 8 gram and chlorine is 14.2 gram. So first we are going to find the number of mole. Mole is 8 by 40. We know mole is the mass divided by molar mass. So molar mass of calcium is 40. And for chlorine, it is going to be 14.2 divided by 35.5, which is the molar mass of chlorine. So moles comes out to be 0.20 and it is going to be 0.40. Now, what is going to be the next step? Now we have to divide with the smallest value. Okay, like divide by smaller value. And how we can do that? The smallest value is 0.2 and like 0.2 as compared to 0.4. So we have to divide it with the smallest value, that is 0.2. Now the answer comes out to be 1:2. So empirical formula is going to be calcium is Ca and chlorine is going to be Cl2. So this is basically empirical formula. Now, in order to find the molecular formula from the empirical formula, there are two formulas which we need to keep in consideration, which is N is equal to molecular formula mass divided by empirical formula mass. And the other formula is molecular formula divided by empirical formula. So now we have this question and they have given us the empirical formula and the molar mass of a compound. They want us to find the molecular formula of an unknown compound. First of all, we should know that N here basically represent a whole number. So first we are going to use this formula and N is equal to, first we have the molecular formula mass which is given, that is 180, and in order to find the molecular formula mass of the empirical formula, it's going to be CH2O. So 12 plus 2 into 1 plus 16, and that comes out to be 30. So N comes out to be 6 here. Now we are going to use the second formula, which is N is equal to molecular formula divided by empirical formula. N is 6 here and molecular formula we need to find out. Empirical formula is given to us, that is CH2O, and molecular formula comes out to be 6 times CH2O. So carbon becomes 6 here, hydrogen becomes 12 here, and oxygen becomes 6 here. Then we are going to discuss about the composition of mixtures. As we know that the pure substance, they basically consist of, uh, they have the fixed composition. We know they have the fixed composition. And we know the pure substance could be aluminium, and it could be a molecular compound, water, or could be hydrogen gas. Even the formula units of NaCl, NaCl is ionic compound, so we use formula unit for it. Then we have calcium carbonate, the formula unit of calcium carbonate. See, so they all have the fixed composition. But on the other hand, if you are going to see mixtures, then what happens in mixtures that their composition is not fixed. Their composition is not fixed. They could contain two or more type of atoms, molecules. They contains two or more types of atoms, or they could be molecule or formula units. So they don't contain only one type of atom or molecule or the formula unit, but can contain two or more than two. Like for example, we have air, which contains oxygen, or that contains also nitrogen, and even water and oil, they are also the mixtures. Now mixtures, they have also certain types. The one is going to be homogeneous. So mixture has also certain types. The one is going to be homogeneous, which have the same composition throughout. Like we can say air. Air is a homogeneous mixture. We know that from whatever place we would get air, it's it is the homogeneous. It has the same composition throughout. Like it contains uh 78% nitrogen, and it contains 21% oxygen. And the heterogeneous mixtures, if we see about the heterogeneous mixtures, their composition doesn't remain the same. Okay, and it basically varies from one mixture to another. So its composition varies from one mixture to another. Like for example, now we have the elemental analysis. Let's see about the elemental analysis. The type of question that would come in elemental analysis, let's discuss about them. So in this question, they are saying a 4.1 gram sample of mixture of calcium chloride and magnesium fluoride contains 0.3 gram of calcium, and they want us to find what is the percent of calcium chloride in the sample. So they have given us only the mass of calcium, but we want, and this is the total mass. Okay, now how we need to solve it? First we need to find the total mass of calcium chloride. Okay, how can we do that? First we are going to find out the mole of calcium, that is mass of calcium divided by its molar mass, and that comes out to be 0.00749 mole of calcium. Now we are going to use a table method. And what does the table method suggest to us? That we know we have 0.00749 mole of calcium, and 1 mole of calcium chloride contains how many mole of calcium? Only 1 mole of calcium. So what will happen? This would cancel with this, and the answer 0.00749 would be multiplied with this one, and it comes out to be 0.00749 mole of calcium chloride. Okay, now we are going to find out the mass of calcium chloride. For that purpose, we know mole is equal to mass over molar mass, and we want to find out the mass. So here mole will be multiplied with the molar mass, and moles are 0.00749 times it with the molar mass, that is 110.98 for calcium chloride. Okay, this is for calcium chloride. Now what happens? The answer comes out to be 0.83 gram of calcium chloride. So now we have the total mass, which is 4.1 gram, and the mass of calcium chloride is 0.83 divided by 4.1 times it with 100. So we are basically finding the percentage of calcium chloride in sample. So total is 4.1 times it with 100, and the answer comes out to be 20%. Okay. Now the last thing we are going to discuss is purity. So what does basically purity tells us? It tells us that it is basically the extent to which a substance contains only desired chemical compound. And we always express purity in percentage. Now let's see a question. Okay, now there's a formula for purity. The purity is mass of desired compounds divided by total mass of sample times it with 100. So this is the formula. So there is a question. They are saying the 5 gram of NaCl were analyzed, and it was found that it was contaminated with sulfur. The sample is determined to contain 1.35 gram of sodium, 2 gram of NaCl, and the rest is sulfur. So basically, the sulfur is basically an impurity. So we have the formula, that is mass of desired compound. So mass of desired compound here will be of sodium, and that of chlorine, because they are the mass of desired compounds, and the rest is sulfur. So total mass of sample of NaCl is 5 gram. This is percentage purity, and times it with 100. So the answer comes out to be how much? The answer comes out to be 67.0%. This is percentage purity.